So graphing quadratics, we started doing this yesterday. So you can see here that we're going to be graphing things that are in the form ax squared plus bx plus c. But to start it off, we're basically going to start with something that is just ax squared. Okay, so when we have something that is y equals ax squared, it's the most basic type of graph that you could have for a quadratic. Remember, we talked about before that y equals x squared is what we call the parent function. It's what all of the quadratics start from, and then we just make changes to that equation where you might put a number in front of the x squared, or you might put a number before it or after it. Okay, and we also talked about the direction and the width of a graph. So that if you have y equals ax squared, we said that when a is greater than 0, you could end up having a certain type of graph. So we're going to look at what happens here when you have a is greater than 0, so that means y equals something like 2x squared. You end up having a graph that opens up. If you have 6x squared, 6x squared, again, your graph is opening up. So as a little summary, whenever we have that number in front of the x squared greater than 0, remember we know that the graph opens up and the vertex is a maximum. And you may want to write that down for yourself. So if you need to pause the video throughout, pause it as you need to. The graph opens up and the vertex is a maximum. The graph opens up and the vertex is a minimum. Sorry, typo. Minimum. So you have your graph. You may want to draw a sketch for yourself. So your graph will look this way when a is greater than 0. When a is less than 0, that means that it will be a negative number. So if we go to our graph here and we change this 6x squared to a negative 6x squared, we notice that the graph all of a sudden flips. If we keep that as a negative, it's still staying upside down. So remember yesterday we said that when we have our graphs, if a is less than 0, that then we have, come on, where is it? So then we will have that the graph, you may want to write this, opens down, and the vertex is a maximum. And then draw yourself a picture so it opens downwards this way. Okay, remember the vertex is your highest or your lowest point, or your maximum or your minimum. Here it's a maximum, here it's a minimum. So you remember that we use the word vertex. It's that point where the graph changes. Okay, remember the vertex of all quadratics in the form ax squared is 0, 0. So you want to make sure that you have that also. Okay. Something else to know that we talked about yesterday was sometimes the value of a can change how something is. Remember, the smaller the value of a, the wider the parabola. Okay. And the larger the value of a, the more narrow the parabola. So you may want to write some of that down for yourself. Now, axis of symmetry. Axis of symmetry is actually a very important equation that you're going to need. And the axis of symmetry is the equation of the line through the vertex. So when I have a graph, if I have here a parabola drawn, I have my parabola and I have it drawn just like this. My axis of symmetry actually goes right through the vertex here. And it's going to be a vertical line, so it's going to have a particular equation. Remember, all vertical lines start with x, and in this case, the axis of symmetry is x equals 0. If I have a graph here where I draw the axis of symmetry over the parabola, over here, and I tell you that this is the ordered pair -3, my axis of symmetry goes through that vertex. And instead, my axis of symmetry equation is going to be x equals -3. Okay, so your equation of the line through the vertex is always going to be x equals some number. It's going to have whatever the vertex value is going to be. So it's the x value of your vertex. Okay, so what I want you to do now is I want you to pause the video because you're going to come back to it, and I want you to go to Brain Genie and I want you to complete these 2 Brain Genie goals and be successful on those 2 goals. Once you have finished those 2 goals, I want you to come back to this video to see the next page. So now let's see what happens when instead of changing just the a value, we add in a c. We're going to add in a constant. So we're going to look at that Desmos graphing calculator again, and it says describe what happens to the parent function when you have y equals x squared plus 1. So I want you to tell me what happens to the graph. How does it change? So we would have y equals x squared, remember, as the parent function. When I add 1 to that graph, what happened? Well, the graph moved up. Oops, sorry. The graph moved up. So we would say what happened to the change? Well, the original function moved up 1. If I look at y equals x squared plus 5, instead change that, we have y equals x squared, and I'm going to add 5 to it, we'll notice that the graph moved up 5. So the original function moved up 5. When we have x squared minus 3, we start with x squared, remember, and we subtract 3, what happened? Well, it looks like our graph went down 3. Okay, so the original function moves down 3. What do you think is going to happen when we have y equals x squared minus 7? Well, let's find out. Y equals x squared here, and then minus 7. Oh, look at that. It jumped down even further. It's now down at where negative 7 is on the graph. So the original function moves down 7. So if we have to summarize, when you have an equation in the form y equals ax squared plus c, if c is greater than 0, then your graph is going to move, and instead of moving the width or the narrowness of the graph is going to slide up a value of c if c is greater than 0. So if you have a positive, or you're adding something positive to the graph of x squared, it's moving up that number. If c is less than 0, the graph is sliding down whatever number you're subtracting from the graph. So you're going to want to write these two things down. Okay. Is the vertex still at 0, 0? Well, if we go and look at that graph, is our vertex still here at the origin? No, it's not. Okay, when we did x minus 3, it still wasn't at the origin. When we did x squared plus 5, it still wasn't at the origin. So the vertex still moves depending on when you move it up or down. So no, the vertex is not still 0, 0. It's actually whatever 0, comma c will equal. But that only works when you have y equals ax squared plus c. Your vertex is always going to be whatever 0, comma c is. Okay, so if you need to review any of this, go ahead and review it. And then I want you to go and I want you to complete Brain Genie goal, y equals ax squared plus c, and complete it successfully.